Our sun is roughly 150 million kilometers away from us. When we see pictures of sun in the space, it looks like a huge white flashlight with a black background. But on Earth, when we look up at the sky, the sun looks yellow and the sky looks blue. Surprise, surprise. When space looks like this, why is the sky blue? This is concerned with three things: the energy carried by different colors of light, the particles in our atmosphere, and the way we humans perceive colors. Firstly, the sun is not yellow, it is white. The sun emits radiations across the electromagnetic spectrum consisting of X-rays, ultraviolet, visible light, infrared, and even radio waves. But human eye can perceive only the visible light wavelengths, which are the same as those you see in a rainbow, namely violet, indigo, blue, green, yellow, orange, and red, or Vibgyor. When you mix all those colors together in proper proportions, you get white, and that is why white is the true color of the sun. Light has a constant speed, but different kinds of light carry different energies. In the visible spectrum, violet carries the most energy and red the least. This energy difference is depicted in the wavelength of the light. But because the speed of light is constant, violet light makes more oscillations in a unit length than does red light, so its wavelength is smaller. Our atmosphere contains a variety of air molecules along with dust particles. These particles are usually a few nanometers in size. Compare it to the wavelength of red light and violet light. Violet light, due to its shorter wavelength, has a higher probability of colliding with these particles and scattering than does red light. This means that red light does not scatter much and is robust over long distances. This is the very reason why red light is chosen for signals like danger signals and traffic lights. Colors near the violet end of the spectrum scatter the most and give the sky its color. This is called Rayleigh scattering. But why then is the sky not violet? This is because of three reasons. First, the cone cells in human eye perceive blue light much better than violet. Second, the oxygen in the atmosphere absorbs wavelengths at the edge of the ultraviolet region of the spectrum, reducing the amount of violet light. And third, the light emitted by the sun contains more intensity of blue and green color as compared to violet. In fact, among all the visible colors, green light is the most plentiful in sunlight. But it isn't scattered as readily as blue light. So the end result is that we see blue light coming from the sky. And this is why the sky is blue. But why doesn't the space look blue? This is because in space there are no atmospheric particles, and so there is no scattering of light. Therefore, only the sources of light look bright and the rest are black. On Earth, all the blue light from sunlight is scattered away in the atmosphere. The remaining visible colors of sun add up to make it look yellow. Rayleigh scattering is very tricky. It only takes place when the atmospheric particles are smaller than 1/10 of a micron, that is 1000 times smaller than the thickness of your hair. But if the atmospheric particles are bigger than a few microns, then they scatter all the wavelengths of light equally. So the resultant light becomes a mixture of all the colors, which is white. This is called Mie scattering. Clouds contain water droplets which are bigger in size and scatter all the wavelengths of light equally. And this is why the clouds are white. Side fact, an average cloud like this can weigh around 500,000 kilograms. Dust particles in the atmosphere, which are larger than 0.5 microns, also cause Mie scattering. Ever noticed how the color of sky fades to white as you look towards the horizon? Light scattered from the top of the sky is perpendicular to you and covers less of atmosphere to reach you. As such, it gets scattered by less dust particles in the atmosphere and is deep blue in color. As the angle of incoming light increases, the length of the atmosphere it covers also increases. Hence, it collides with more dust particles and gets scattered more. This is the reason why the sky gradually fades to white towards the horizon. When you look at the horizon, you're looking at light which is almost parallel to the surface of the earth. This light gets the most Mie scattered and is hence almost white. This is also the reason why nearby mountains look sharp green and brown, but the distant ones look almost white. But when the sun is at the horizon, light coming off it covers an enormous section of the atmosphere. By the time it reaches you, almost all the blue light has scattered away. What is left of it are the red and orange colors. This is the reason why sun looks reddish during sunrises and sunsets. The density of the atmosphere also has a say in the color of the sky. It is a well-known fact that while blue planet has red sunsets, the red planet has blue sunsets. Mars has less than 1% of Earth's atmosphere, So only when sunlight passes through the greatest thickness of Martian air does it get enough particles to scatter blue light. Hence, the sunrises and sunsets are blue on Mars. This is how science can make one thing look so different in different worlds. And that's just Mars. Imagine how would sunsets and sunrises look on different planets. But no matter where you are, science will always have its way to beautify nature. And as always, thank you for watching.